This is a description of a model of an Army Dukw. The hull is built from polystyrene flat sheets and which are cut to profile and then assembled. The running gear underneath consists of a KingKong RC 6-wheel drive truck chassis, which fits very snugly in the space. Here's the view as we're turning it around. You can get a general idea of what it looks like. And we'll now move to running the thing flat. We're just running on flat ground here to make sure that it steers and has a reasonable turn of speed. That's really as fast as it will go in this particular setup that I have. I was concerned about the speed because I also wanted to have enough torque to be able to climb reasonable slopes. And so what you'll see now is it ascending a slope of approximately 25 degrees, which is a reasonable slope. And it goes up there very easily, and on tests that I haven't shown you, it accelerates up the slope without any difficulty at all. This should be a reasonable representation of the sort of gradient that it's likely to see, since we obviously need to be able to get out of the water promptly. We also use a propeller when we're doing that as well. And here's will be a second run of that particular shot. And what happens is the back tends to stick there, you see, right there, because it's just bottoming out. That really sets the maximum angle that we can really climb at. Alright, so that runs quite satisfactorily. Now we've got to look at the underside. This shows the running gear, and you can see it's all 6 wheels are being driven right now. Bit of dirt on the tires so you can actually see that they are actually turning, and note that the propeller isn't rotating at the moment because it hasn't been engaged. We're just driving the road wheels. Now we turn on the prop and you can see the prop running, and the prop will run independently of itself in either direction. And also you can run both this is the steering, I should say, right now. You can see the steering is compatible front to back, as in the real vehicle. Both the front wheels and the rudder steer because they both provide navigation control underwater. When you look topside, you can see the steering action. You can see there's a steering wheel I've got there which is turning, and also the rudder at the back. A little hard to see that. I fitted a winch on the back which is driven by an electric motor, electric winch, and a momentary switch. So that's what that looks like. I could have run that remotely with the radio control, but I wasn't sure whether I should do that. Okay, now we take it out and give it a run in the water. This is its maiden voyage on this very placid day. It sails out, seems to go fine. I was concerned about the size of the rudder and whether or not it would have adequate authority, but as you can see, I make the turn, it's got a lot of authority, the rudder, so there's no concern on that particular score. It does run a bit nose down at the front, which is not what I really want. Now you'll see it comes out, I've engaged the road wheels and I can bring the thing up out of the water. So normally you just run with the propeller underwater and you wouldn't be running with the road wheels. Going back in now, whoops, we come to a stop, turn on the props and then get the drive running and off we go. So it does need a bit of balance to try and get the nose up a bit, and I will be figuring out what the trim is for that and setting that. Unfortunately it means adding weight at the back rather than taking it off at the front, but that's just the way it goes. Well, that completes the dynamics test. This is a picture of an assembled duck hull provided by the manufacturer of the materials of the product. What you get from him is a set of cut sheets that are of the scale that you wish. In my case, 1 in 12. These flat sheets are then assembled, and we show the first assembly here where the pieces are clamped together. You really have to make sure that you get everything very square because it can get out of hand in a real hurry. What I do is I also made some additional cuts in the decking because I was having to add machinery and I needed some extra space in the area. So it's done on a milling machine to make it nice and straight. Then what I did is I applied this excellent glue weld-on and I clamped the assemblies together, and so you get a sense of what that's like. And that's all done. We have a look at the side of the vessel, and what we see is that there's some extra pieces added around the edge so that there's a good bond for the side plates that have to go on and make it all watertight. And now we see the underside, and the thing is, you know, coming together pretty nicely. You can see the prop shaft in place and so on. Here's the picture of the thing, almost ready to have the side cheeks put on and ready for its water test when that's done. And so here's again another view of that. This is what we're looking at right now. Okay. This is the underside after the side sheets have been put on, and I also painted with matte black enamel the bottom because that needs to be pretty sturdily corrected. Well, when the hull was put into the water, there were a large number of leaks because it was very hard to get watertight connections, and you couldn't see where the leak was coming from. So I ended up filling the inside of the hull with water, and then I was able to see where it leaked out, and then I was able to fix the leaks. So that was an important change. This is a picture of the hull underside showing how the chassis of the KingKong RC truck fits. Fits very neatly, I think, and you can also see the prop as well. Here's a picture of the components of the running gear. Prominent, you can see the main propulsion motor at the bottom right, and also the propeller motor at the left. On the top side, this is how they're installed. Nothing very much to say there. This is the schematic, and basically there is a single ESC that will drive either the propeller or the road wheels depending on how you switch them. You can run them both together or not. So this is analogous to the full-size machine, which only has a single propulsion unit. There's a power hitch at the back, the switch with the momentary switches to make it go fore and aft. The front lights are on all the time when the boat is powered up. Turning now to the main specifications, you can see what it's made of and the scale, and also what the running gear consists of. The running gear certainly has enough power to do the job, as the accompanying videos have shown. Nothing too much else to say about that. Note that the whole package weighs 11.23 pounds, which is a bit heavier than I had hoped for, but nevertheless the system seems to operate satisfactorily. So I guess we'll declare it a victory after all.